All right, welcome to applications of similarity. So at the top of your notes, you can see it says applications of similarity and congruence. That was a mistake. It's just similarity. So you can just cross that out. Because applications really only work if the two triangles are similar, because what they let you do is if you know the height of one thing and how far away those two things are from each other, then you can also figure out the height of something else because of similar triangles. So let me show you how this works. It says Aaron, who is 1.6, M stands for meters tall. So you can see here that Aaron is 1.6 meters tall. Cast a shadow, and this is her shadow right here, that is 1.25 meters long. Her shadow happens to also extend to the end of the tree shadow. So like the tree shadow is like all the way to right here, and they happen to touch at the end. Okay? When she stands 4.75 meters away from the tree. So that's how far away she needs to be from the tree so that their shadows match at the end there. So they want to know what's the height of the tree. Well, the easiest way to deal with this, always, when we're doing similar triangles that are like triangle within triangle, because you see how this is like a tiny triangle within this bigger triangle, it's usually always easiest to separate your two triangles. So then you can see what you're working with. So for example, the little girl's triangle, she's 1.6, and then this is 1.25. For the tree's triangle, we don't know this, right? However, we do know this is this 4.75 plus this 1.25. So when we put them together, it's actually 6 when you add them. So first of all, let me remind you why these two triangles are similar. They're similar because right here, this tree is a straight up and down line, so it's perpendicular to the floor, and it creates this right angle right here. Also, the girl stands perfectly up and down on this floor, and so it creates a right angle right here. So there's two angles that are the same. And then this angle right here, from the edge of the shadow up to their heads, it's the same for both of them because it's a shared angle. So because of angle, I know the two triangles are similar. They have to be. Which means somehow I go from 1.25 to 6. So to figure out how I do that, I do 6, the second one, divided by 1.25, the first one. And when I do that in my calculator, I get 4.8. Which means, to go from here to here, I times by 4.8. Which means to go from here to here, I need to times by 4.8. So, 4.8 times 1.6, which is her height, is 7.68. So the tree is 7.68 meters tall. When you answer word problems like this, you need to include the units. So like it's an M, it's in meters, you need to say M because it's in meters. Okay? And that's basically it. That's how you can apply similar triangles in this way. It's often by figuring out heights.